Alright, hopefully you're getting the hang of finding sides using trig. As I mentioned in the previous video, we're actually going to be able to use trig to find angles as well. Okay, so instead of finding sides, we're going to use our ratios to find angles. Again, keep in mind that these ratios are just a comparison of two sides, whether it's the opposite and hypotenuse, adjacent, hypotenuse, whatever it is, it's a comparison. So the calculator does all the work based on those sides. So again, we can also use trig to find angles in right triangles. It has to be right triangles still. To find an angle, we will use either the inverse sine, the inverse cosine, or the inverse tangent buttons on our calculator, also known as arc sine, arc cosine, arc tangent. And I'll show you how to use that here in a second. So find the angle measures using the inverse buttons on your calculator, round to the nearest degree. So for example, the sine of A, again, I'll put up right here. This is still SOHCAHTOA, so we're still getting practice with it. The sine of, so for example, if the sine or the relationship, the ratio between the opposite and the hypotenuse was 0.8230, okay? So basically the opposite is 0.823 of what the hypotenuse is. It's just a comparison. If we knew that, our calculator is going to allow us to find what the actual angle of it, or what the angle is for A. So what we need to do, so let's see, 0.8230. Write that down so I don't forget. If we go to our calculator, again, make sure you're in mode, make sure you're in degrees, always double check. And what we do is we take this second button and hit sine, and you can see blue there, that's the sine, or the inverse sine at sine -1 there. So we take the inverse sine of 0.8230, and what it's going to do for us is it's going to pop out a number that gives us our actual angle. So 55.39. Or I said round to the nearest degree, so that would be 55, what I say, 55.3, so that would be 55 degrees. If we did number or letter B, tan of A, so we would go 0.5038. Okay, so let's go ahead and do this. So we would do second tan of 0.5038, and again, we're just getting practice here, and it's going to pop out a number, 26.7, which tells me to go to the nearest degree would be 27 degrees. Cosine of 2/3, we can still do that, so we're going to do the inverse cosine, the inverse cosine of 2/3. That's still a ratio, it's just not in decimal form. That's okay, that's what we're actually more used to. So we get about 48 degrees. And the sine of 14/18, we should always really reduce that to 7/9. Doesn't matter if it's reduced or not because the calculator reduces it for you, but good habit to make that inverse sine, inverse sine of 7/9, so inverse sine of 7/9. Tell me what number or what angle that would be then, and about 51 degrees. So again, it's just taking the ratios and computing an angle based on it. Okay, so pretty cool stuff that the calculator can do for us. So for the following problems, solve for the given variables. Round angles to the nearest degree and size to the nearest hundred. So we're going to do a little bit of practice with both here. So let's go ahead and say, let's start with what we just talked about. So we're going to find that angle there. So we want to find x. So if we want to find x, we're actually we always start with an angle. So to do that, what we're going to do is set up and say, okay, if I want to find x, how do I compare 12 and 20? Well, 12 is an adjacent side, 20 is hypotenuse. Okay, so which one are we going to use if we are talking about adjacent hypotenuse? That's A and H. We're going to use cosine. So what we're going to do is set up the cosine of x is equal to adjacent over hypotenuse. Okay, and if we're actually solving for x, think of it this way. We actually want to do the opposite of cosine. We want to take the inverse here. So let's go ahead and make it look like this. What we want to do is think of it as dividing by cosine and canceling on both sides. And if you do really dividing by cosine is the inverse. It's doing the opposite. So we don't have to write that step, but I wanted to show you where it's coming from. So we really have the inverse cosine of -1 of 12 over 20 equals x. Okay, so again, that's what we're looking for. We're just taking the inverse cosine. So let's go ahead and do that. So inverse cosine, and I'll let you guys punch it in your calculator. Second cosine, hit 12 divided by 20, and we get x to be, let's go nearest degree, I believe I said, 53 degrees. Okay, now y, we're going to do same kind of idea. And the nice part is, if we know this is 53 degrees, we don't actually have to use trig to find y. So what we can do here is 180 minus 90 minus 53, and our leftover is going to be, let's see, 37 degrees, and there's y. So you are more than welcome to do that. Nothing's saying you have to use trig. We need to use trig sometimes, but you don't have to in certain cases. Okay, let's look at the next one, where we actually have to find some sides. So let's start with angles still, and we'll focus on x. So if we have x here, what we want to do is decide what the relationship is between 6 and 15. Well, 6 is an adjacent side, 15 is a hypotenuse. So adjacent and hypotenuse is a and h. So we're going to start with the cosine of x equals 6 over 15. Again, we'd be thinking we would divide by cosine, which leaves us x, and cosine dividing is really the inverse. Because you don't really divide by the cosine, but that's how we're thinking it. So you do second cosine, so the inverse cosine of 6 over 5. Oops. Inverse cosine of 6 divided by 5. Oops, 15. No wonder it was giving me an error. Second cosine 6 over 15, that'll give us something good. So we get about 66 degrees. So this is 66 degrees. Again, to find z, go ahead and just do 180 minus 90 minus 66 to get your leftover. So that would come out to 24 degrees. Now y is like what we talked about in the previous video. So to find y, you can start at either angle 66 or angle of 24, and then do another comparison, except for we won't use the inverse cosine here, only when finding angles. So let's look at 24. I'm going to focus here. We have 6, we have 15 we can use. So you have multiple options here. I know I have to use the adjacent because y is next to 24. And then from there I can kind of pick. So I'm going to use adjacent and I'm going to use hypotenuse. So adjacent hypotenuse, that's the cosine of 24, is equal to the adjacent, which is y, over hypotenuse, which is 15. Okay, you could have also used the tangent of 24 is 6 over y and done the same thing. It doesn't matter. Multiply. Oops, I don't want to do it like that. I've been showing you guys a little bit different way that I think would be better. Cross multiply, so we have 15 times the cosine of 24 equals y. Again, punch that in your calculator without the inverse, so 15 cosine 24, and you get y to be about nearest hundredth, 13.7, and that would be 0, because the next number was 3. And I would strongly suggest that you are doing this on your calculator as I go through it. If you don't, you are going to be lost. Okay, so make sure you're not just coasting through doing what I'm doing. Let's look at a couple more, and then we'll save some more for class tomorrow. We have a bunch that we can work through. So number 4, let's look at what we have. Okay, and you have now come up with 3 different ways to find sides and stuff in a triangle, sides and angles. You can use Pythagorean theorem, you can use special rights, you can use trig. Okay, so let's keep that in mind as we work through these. In number 4, you can see that you're only given a couple of things. You're given 2 sides and a right triangle and an unknown third side. So if you wanted to, you could use Pythagorean theorem to find y. We have w, we have x, we're going to have to use trig to find that. We have z, where we have the entire thing. So we have a lot going on. It doesn't really matter where you start. So I'm going to start by finding the angles. So if I'm looking at w, w has an adjacent side and a hypotenuse. Okay, a and h, if you go back, a and h is cosine. So the cosine of W is equal to adjacent over hypotenuse. Again, you'd think of this as dividing both sides by the cosine, so W is equal to the inverse cosine of 12 over 15, so inverse cosine 12 divided by 15. W equals about 37 degrees if we round to the nearest degrees. So there's W, so I'm going to go ahead and just mark this as 37 degrees. If that's 37 degrees, up here has to be 53 degrees, because again, triangle sum, they all add up to 180. Okay? So we have that taken care of. To find Y, well, if we find Y, we know what Z is, because Z is the whole thing, and Y is this, Y is that. So let's find Y by doing one of two things. We can either use Pythagorean theorem, which is fine, or we can use trig. I'm going to use trig since that's what we need to practice. So I'll start with 53 in this case. Again, you could start with 37 if you want. So 53 degrees, and I already know I have the opposite, I have hypotenuse. So I have a couple things at my disposal for what I want to use. Y is the adjacent. So I know I need adjacent. So I'm going to do adjacent over hypotenuse. A over H, that would be ka, so that would be cosine of 53 equals adjacent over hypotenuse. And again, cross multiply, you have Y equals 25 cosine 53. Punch that into your calculator, 25 cosine 53. Y comes out to be about 15.05. We'll go to the nearest hundredth, because that's what I believe I said earlier. Okay, so we have that. Again, it's practice. It's not that easy to figure out what your relationships are. You will get in the habit of SOHCAHTOA. You will know which ones to use quickly as you get more practice with it. I said if Y was 15.05, then Z is just double that, so Z we would say is about 30.10. Okay. So again, different parts, all based on relationships, things we've used with special rights. Let's look at another double triangle. This is very similar to what we did with special rights, just different ways of finding them. Okay, so let's start really wherever we want. So I'll go ahead and start, actually we can't start wherever we want, because if we tried to find anything over here, we only have one side to compare it to. Okay. So, and we don't have any angles there, so we can't start there. We have to start on the left side. That's where we have more information. So 37, we're going to start here, and we know that we have the opposite, which is x. We have the hypotenuse, which is 16. O and H is sine. So it's sine of 37 equals opposite over hypotenuse. Cross multiply, x is equal to 16 times the sine 37. Punch that into your calculator. X comes out to be about 9.63. So there's X. So I'm going to get rid of this X and make it 9.63. That's like a special race. We're going to move it and use it for the other triangle. So now to find Y or Z, either one, because if I find one, I know the other one, because we can use triangle sum. So I'm going to try and find Z, just because. So Z's relationship with these two sides is adjacent you have, and you have hypotenuse, A and H. A and H is cosine, so we're going to do cosine of Z equals 9.63 over 12.2. Again, if you know that, what you're going to do, I don't know why I did that around it. If you know that, what you really want to do is think of it as dividing by cosine, which is taking the inverse cosine or arcsine of 9.63 over 12.2. So inverse cosine, second cosine, and we have 9.63 over 12.2. And it comes out to be about 38 degrees for Z. So Z is 38 degrees. We can find Y by just going ahead and doing our leftover. So 180 minus 90 minus 38 is going to be 52 degrees for Y. And again, if it's an angle, make sure you have degrees with it. Okay. Again, this is not that easy. You have to make sure you are comparing sides, you're setting it up. Make sure you go back and re-watch if you think you're close. Okay, come in if you want some extra help. Let's do 6 and 7 together, and then we'll call it quits. So in 6, okay, what we have here, you got to think about where you want to start, and if it doesn't work, it doesn't work. Start somewhere else. So what we have is this angle is 40 degrees. So I'm going to focus there for now. And I know that I have an adjacent side and I have a hypotenuse because it's across from the right angle. So A and H. So I'm going to use cosine. Again. So doa. So I'm going to use the cosine of 40 degrees is equal to adjacent over hypotenuse. Cross multiply, y is equal to 4 cosine 40. 4 cosine 40. Y is about 3.06. So there's y. And now I just keep going. To find x, that is an angle. So again, we still start with the angle, but we have to use inverse. So we know that we have opposite, which is 2. We have the hypotenuse, which is 4. Opposite hypotenuse, that is the sine of x, is equal to 2 over 4. Divide both sides by sine. So that's really taking the inverse sine of 2/4. So x is going to come out to be inverse sine of 2/4. And we come out to be exactly 30 degrees. So one that works out pretty nicely. Okay? So far so good, hopefully. Moving on. Looking at number 7. Okay? This is one that's a little bit tougher. We have a little bit going on. And we're going to try and break this up into a couple pieces. First of all, we know that we have no angles, so we can't do anything with our trig functions for finding sides, because we don't have any angles besides that 90. That one doesn't work. But we do know that we have 2 sides. Okay? So if we want to find the third side, you could use Pythagorean theorem. You could figure out one of the angles first and then use trig. So let's go ahead and figure out some of our angles first. We have a few that we need to complete. So let's say that this is x. Okay, let's look at x first. We know that we have the opposite of x, which is 18. We have the hypotenuse to x, which is 27. So let's start there. Sine of x is equal to opposite over hypotenuse. Again, this ends up being the inverse sine of 18 over 27, which is equal to 42 degrees is what we'll call it. So there's x, so instead of it being x there, I'm going to go ahead and get rid of it and write that this is 42 degrees. Okay. So we have that so far. Find the other ones, it's going to be a little bit tougher. Okay, so what we're going to need to do, and we're kind of in a pickle here, because if we try to find w or y, so for example, let's try and find w. If we did that, we don't have 2 sides to compare it to, so we can't do that, because we need 2 sides to compare before we get an angle. Same thing with y. We can't compare y to anything because we only have 18. 27 doesn't go with that triangle. 27 is for the big triangle. So we need to move on to finding z, and then maybe go back and find w and y. So to find z, that's an entire side, we can go ahead and say that based on this one angle we have, z is the adjacent angle, and I'm going to use either opposite or hypotenuse. Doesn't matter which one you use. I'm going to use opposite. So I'm going to use O, opposite, and A, adjacent. So that's the... I went back and fixed it, so sorry for that little glitch there. So I was saying that it's the tangent of 42 degrees is the opposite, 18, over the adjacent, which is z. Opposite over adjacent. Cross multiply, so that's z times the tangent of 42 equals 18. Get z by itself by dividing both sides. And z is going to come out to be about 18 divided by tangent 42. 19.991, so we do have to leave it as 19.99. So that would be Z here, 19.99. Okay, now that we know that, what we can actually do is go ahead and say, and let's just, for simplicity, I know it's really close, so let's just go ahead and call that 20, because that'll help us see these a little bit easier. So we'll go ahead and call that 20, which means that this is 10, and that's 10, which is going to help us for our last part. So all we have to do is find y or w. Once we find one, we know the other. So it's the last part, and then, like I said, we'll save the last couple for tomorrow. So to find y, for example, we can compare y to 10 and 18. So that would be opposite and adjacent. So that's the tangent of y equals 10 over 18. So that's really the inverse tangent is what we're trying to find of 10 over 18. Punch that in, so inverse tan of 10 over 18 comes out to be about 29 degrees. So there's y. So we know that's 29 degrees, which means we can find our leftover of w, which is 61 degrees. Okay, so we have everything down, everything works out. I know it was a longer video. It's not an easy subject. The calculator does the work once you have it set up. It takes a little bit of kind of comparing and using your SOHCAHTOA to get your stuff set up. For angles, you're using inverse. When you try to find sides, you just use your regular sine, cosine, tangent. I will see you guys tomorrow, and we will look at doing 8 and 9 together to make sure we're all on the same page. Adios.